Hello students. So we were doing differential equations and the subtopic was integrating factor, that is solution of a differential equation using integrating factor. Okay, so we'll solve some more problems. Okay, so let's solve. Dy by dx x cot y, this is dx by dy. Okay, 2y plus y square cot y. Okay, so let's solve this. So it is given in the form dx by dy, so we have to write it. This will be our cot y into x. Okay, so y terms you have to take. This becomes your p and this whole thing is your q. Okay, so integrating factor is e raised to integral p dy. Now we have to integrate with respect to y. So integral cot y dy. So integral of cot is log of sine. Okay, so en log goes, so you will get sine y. Now you have to substitute in that x into integrating factor equal to integral of q into integrating factor dy plus c. Okay. X into integrating factor is sine y, integral of 2y plus y square cot y into sine y plus c. Okay, now take this sine y inside, so this will be integral 2y sine y plus y square. I can write cot y as cos upon sine into sine y dy plus c. Okay, I have not written here dy, so this will be cos y. Okay, so two terms will get 2y sine y and y square cos y. Okay, now you have to integrate. So I am going to write this term as it is, that is 2y sine y as it is, 2y sine y dy. I am just going to integrate this term, that is integral of y square cos y. Okay, so using that LIT rule, so this becomes your first function, this becomes your second function. Okay, you have to integrate it by using parts. So y square integral of cos y, which is sine y, minus integral of derivative of y square 2y and integral of cos y, which is sine y. Okay, dy, and here our c is there. Okay, so these two terms get cancelled. Okay, so you will get only this term y square sine y plus c. So I will write here x sine y equal to y square sine y plus c. You can take this sine y this side, so it will be x equal to y square sine y upon sine y is 1 plus c upon sine y. This is our new c. I can write it as bigger c. Okay, so this is our general solution. Now here some conditions are given. Okay, I will write them. at x equal to 0, y is pi by 2. This you have to substitute here to get the particular solution. So x is 0 and y square, so pi by 2 square plus c. So from this c is minus pi square by 4. Okay, this you have to substitute in the general solution, so you will get x equal to y square minus pi square by 4. So this is our particular solution. Okay, let's solve this. So first you have to write it in the form dy by dx plus py equal to q. Okay, so I'm going to write here 1 and this whole term into y. So this becomes our p and this is our q. So let's write the integrating factor e raised to integral 1 upon x log x dx. Okay, so now you can identify this, that is the derivative of log x is 1 by x, right? So this becomes f dash of x upon f of x dx. So integral of this you can write it as log of f of x. So here our f of x is log of x. So integral, this whole thing becomes e raised to log of x. Okay, so e and log goes, so you will get x. Log x into e, so log e is 1, so you will get x as the integrating factor. Now y into integrating factor equal to integral q is our 1 by x into x plus dx plus c. So integral of 1 is x plus c. So your y, x you can take here, so y is 1 plus c by x. So this is our new c. This is the answer. Okay, let's solve this. So first you have to write it in the form dy by dx plus py equal to q. Okay, so you have to divide by cos square x, the whole equation you have to divide. Okay, so you will get dy by dx plus 1 upon cos square x y equal to 10x upon cos square x. So this is our p, this is our q. So integrating factor is e raised to integral 1 upon cos square x dx. 1 upon cos square x is sec square x dx. Integral of sec square x is tan of x. Okay, let's just put this in the equation. Y into integrating factor e raised to 10x equal to integral q is 10x into, now this is 1 upon cos square x, which we can write it as sec square x. Okay, into integrating factor e raised to 10x dx plus c. Okay, here you can take 10x as t. Okay, 10x as t, so your dt becomes derivative sec square x dx. So this term will be this is t e raised to t dt plus c. Okay, so t e raised to t dt, you have to apply the uv, that is integration by parts. So t, integral of e raised to t is e raised to t minus integral, derivative of t is 1 into integral of e raised to t, which is e raised to t dt plus c. Okay, so this is t e raised to t minus integral of e raised to t is e raised to t plus c. So this is our general solution. I will put value of t. Okay. Write it again. So our final answer is y equal to y into e raised to 10x. Okay, t was our 10x, so put that value. T is 10x into e raised to 10x minus e raised to 10x plus c. You can take this e raised to 10x here, so this will be e raised to 10x into e raised to 10x e raised to 10x. So final answer is y equal to 10x minus 1 plus c. This is our general solution. Okay. These are some integration results. Okay, you can use them. Suppose you get a problem involving this type of terms, then you can use this results. Okay, let's solve one problem based on this. Suppose you have dy by dx minus 3y equal to cos 4x. Okay, so here your p is minus 3 and q is cos 4x. Okay, so integrating factor e raised to integral minus 3 dx. So this is e raised to minus 3x. Okay, now you have to find the solution. Y into e raised to minus 3x equal to integral q is cos 4x into e raised to minus 3x dx plus c. Okay, now this is of this type of form, right? E raised to minus 3x cos 4x. So it is of the first form. So let's just apply that result. Okay, write it here. So our a is minus 3, right here. A is minus 3 and b is 4. Okay, so integral e raised to minus 3x cos 4x dx becomes e raised to minus 3x a square. A is 3, right? 9 plus b 16. A is minus 3 cos 4x plus b is 4 sin 4x plus c. So this you get the final answer direct. Okay, so please note it down. Y into e raised to minus 3x. This is our final answer. I will write here only y into e raised to minus 3x. Okay, so this becomes our final answer. So these are very useful formulas. Okay.